Hi, Mike Violette with Espresso Engineering at the 2013 International Symposium on EMC. I'm pleased to be here with Bruce Archambault, and we are going to be working with Bruce on a series of webinars focused on signal integrity and EMC concepts. Bruce, what are you going to present in this six-pack of Bruce?
Well, a number of different things. Some of the more basic things are going to be like the ground myth. I'm a firm believer that the most misunderstood concept in electrical engineering and EMC design in general has to do with the ground, the thing we call ground.
Finding ground.
Yep. You can never be too grounded, right?
Right.
In fact, I have a slide that shows the DNA modules and pointing to a particular gene in there that say that the Genome Mapping Project has actually found why we think ground is good.
It's in our DNA.
It's
at
in
least
our
our
DNA.
EMC engineers'
That's
DNA.
That's exactly right. But then we're going to also talk about electromagnetics for working engineers. I think many of us, when we were in school, studied electromagnetics, and as soon as we were done, we were so glad to be done that class. And
Are you talking those squiggly lines and those curls and stuff? Yeah. Okay.
But, if you're going to do the math, it's very messy. But unfortunately, universities don't usually separate the messy math from the fundamental concepts of the physics that are involved in electromagnetics. Mm-hmm. And that's what I'm going to do here. We're going to talk about the physics and the concepts and not worry about the math. We can look at the math to understand what the physics mean,
but
not try to calculate.
It gives insight to what's going on.
When you try to calculate something, that's when it gets awful. We're not going to do that. But I think understanding the physics can still be very important. And then what we're going to do is go into some more printed circuit board issues like printed circuit board power distribution concepts. How many decoupling capacitors should you have in your circuit board for both signal integrity and EMC? There's lots of different opinions out there. Some people say that you have to use all the same value capacitor. Others will say, no, you have to have a lot of different values of capacitance. Some people will say you need to put the capacitors very close to the ICs. Others say it doesn't matter, spread them out over the entire board. So obviously everybody can't be right here. And so I'm going to look at the fundamental physics of what's going on here in the charge delivery concepts that are needed here to get through some of the misunderstandings and myths that go along with decoupling capacitor design. And then we're going to start talking about some really high frequency things. Nowadays, when we're talking about gigabits and even tens of gigabits per second going through connectors from one board to another board, the concepts that we apply to how we control these things become very important. Mostly these really high speed gigabit links are differential links, and to a signal integrity engineer, a differential link is wonderful because there's no EMC issues. And if only everything was balanced and perfect, that would be true.
Well, we live in an unbalanced world.
It's certainly not true in real life. And so I'm going to talk about the different ways that we can create EMI problems from differential signals and the connectors and so forth, and what we can do about them as well. One of the things that we can do about these really high frequency problems is use something called electromagnetic band gap structures. And so another one of the webinar series is going to talk about EBG's design, which is basically on a printed circuit board, you just take and do some etching of the ground plane and what we normally tell people not to do, make holes in the ground planes. But if you do this just right, you can design them so that it'll be a notch filter at the frequencies that you're trying to avoid.
So is it, are you creating impedances at certain frequencies and controlling current flow, basically?
Exactly.
So these are EBGs.
EBGs.
Right.
And so these EBGs can stop common mode noise without stopping the intentional differential mode signal that you want to get through. And so they're very, very powerful, and they don't cost anything. You don't have to go to the store and buy a part and solder it onto your board. You actually make it during manufacturing.
It's an artwork feature.
Yes, exactly.
Right. And what's number 6 in the six-pack?
And then the final one is to use absorbing materials and lossy materials. Again, as we're getting into very high frequencies, it's becoming easier and easier to use these kind of materials to stop the energy from getting out without having to apply filters. Instead of blocking it or having more shielding or whatever, let's just absorb some of that energy so we don't have to put as much money into making sure our shielded enclosures are almost waterproof, adding very high-cost filter components to our circuitry. And so the whole idea of how do we do this and how do we relate the epsilon and mu, the complex epsilon and mu that we get from the vendor, how do we relate that to what frequency performance I'm going to get when I put it into my product? Up until now, it strikes me that most people will have a box of vendor lossy materials, and they'll try this, they'll try that, and they'll try this here.
Sort of a hunt and peck
It's
sort
a
of
hunt and peck
exercise.
designed by experiment,
right.
basically. But there is some science here, and we can apply that science so that you can come to the conclusion fast and an optimal conclusion, so you don't spend more money than you need to for these materials.
So if you're a design engineer looking at building a system from the smallest component all the way out, you got to start basically at these fundamentals.
Exactly.
So this six-pack of Bruce, as we like to call it, is a series of 6 one-hour webinars, and you can find them on the Washington Labs Academy site. And we're looking forward to delivering this six-pack.
I'm looking forward to it as well.
Mike Violette, Espresso Engineering.